All right, thank you, everyone, each of our panelists, to our audience. Thank you to the Satellite Show, and thank you to ARKA for helping us be here today to be able to talk about a topic that I know is near to each of our thoughts, and I believe to the industry at large. At ARKA, we're passionate about interoperability and open APIs, and in fact, we're proud to release here at the show this week Total Ground, the first truly open software-defined ground architecture. I'd encourage you, if you haven't yet, please stop by and see us at our meeting suite at the top of the elevator. We'd love to help talk through how you can modernize and revolutionize your ground architecture. Some quick logistics. I'll ask each of our panelists to introduce themselves, tell us a bit about the company that you hail from, and where you sit in the value chain for both Satcom and satellites at large. We have a lot of diverse perspectives here, people from ground stations as a service to antennas to Satcom providers. And so we'll be able to bring a wide range of perspectives to that conversation. And then we'll step through some questions. We'll leave time for questions at the end from the audience. So maybe we'll start down at the far end. Trond, if you would introduce yourself.
Yeah, my name is Trond Vegard Rokstad, representing Kongsberg Satellite Service, or KSAT. So we are a ground station as a service provider, mostly targeting the Earth observation market, the space community. Having a lot of ground stations across the world, we currently support around 150,000 contacts per month. That's across our full network of 300 plus antennas around the world. Based out of Norway, Tromsø, Norway. That's about it, I think. We have antennas spanning from 3-meter systems to typically around 13 meters, so supports both commercial customers and also institutes. Myself, I've been working in KSAT as an engineer since 2009, so I'm currently responsible for our future development or further development of our digitized ground station network. Yeah.
Ahsun, maybe we'll come back for Blad.
All right. Hello, everybody. Good afternoon. My name is Ahsun Murad. I'm the co-founder and CEO of Optimal Satcom. We are a satellite communications, resource planning, management optimization company. We do a lot of software systems, enterprise software systems for a number of companies that you see here, satellite operators, service providers, governments here and abroad. We're also a technology, business intelligence, operational intelligence company that works with our customers to make, to bring operational efficiency to their business, technical expertise, and to really help them operate their Satcom-based business efficiently. As a result of what we do, we are working very closely with a lot of our customers. We have a fairly broad exposure to the industry, as a result of which we are able to have insights that cross many different boundaries, market verticals, technology intersects, markets in different regions, different ways of doing things. We see incentives that the government has for operational efficiency, interoperability, ground systems. We see the commercial side of it with partnerships, with competition. So hoping to bring that perspective to this discussion.
Thank you. Blad, if
Yep,
comms are good.
I'm back online.
Awesome.
Thank you for that. So I'm Vladimir Stavropoulos. I am part of the solutions team for Intellian. We are a company that actually at this point manufactures almost everything for Satcom. We do gateway antennas, user terminals, phase arrays, and for the last 20 years, we've grown to be now a large leader on the market across all of them, from military, commercial, land-based recently. And happy to share that yesterday we were able to obtain the type approval for our new full duplex panel on OneWeb. We are looking very well on it and looking forward for other contracts across. And part of this is our recently engagement into the gateways for LEO constellations. It came as a natural evolution of our product portfolio, and thankfully we are also gaining traction on that market every day. So
Wonderful. Congrats and thank you. Paul?
Yeah, Paul Klassen, Senior Vice President of Engineering at Kymeta. So at Kymeta, we're really focused on a hybrid multi-orbit capability for enterprise, governments, MODs, DODs around the world. We really focus on the solutions and use cases of our customers and bring them cutting-edge technology, unlike anything else that you've seen in the industry, from a power efficiency standpoint, from a low observability, and if you think about how our technology really fits into the landscape, we're quite a bit different than any phased array out there. Our antenna design interleaves both the transmit and receive, when that gives us special capabilities that you can't get anywhere else. Now, one of the things that I see is really important for the industry as a whole is interoperability. The capabilities of these APIs that extend the capabilities beyond what even Kymeta can do. We can take an entire industry's ideas and build upon it. And that's really what I see open APIs really extending beyond even what one company can do. And I think this is a fantastic way to kick it off.
Yeah, looking forward to talking about that. I'm also realizing I forgot to introduce myself, so nice to meet everybody. I'm Andrew Strange, Director of Strategy and Business Development for ARKA Advanced Comms and Mission Apps. Okay, so I have questions I'm going to ask. If I have to, I will call on you, but my preference would be for people to jump in and have more of a conversation. Let's start by setting the stage with a hypothetical. If the satellite industry were to achieve fully interoperability, what would that look like for your organization? And then specifically, what would be the immediate and long-term benefits that all stakeholders would benefit from that? From manufacturers, capability providers, integrators, operators, and end users. And by my count, we have a number of those represented up here today, from antennas for the control plane to pretty much everything on the ground side, from a data communication perspective to capacity management, to phased array and multi-orbit, multi-capabilities there as well. And then, of course, ground modems and data processing as well from the ARKA side. So I'll throw that question out there, and whoever feels most passionate, jump in first, but we'll get to you all.
I would start right off by saying that it's going to reduce the complexity of terminals. It will give customers the opportunity to select different hardware providers and plug in different technologies without having to recertify and requalify hardware. So you'd standardize on a single modem, for example. That would change the industry. Very similar to going overseas in the past when you'd carry 2 cell phones. Today, you have to carry 2 modems in our terminal. In fact, there's even more than that, right? So our multi-orbit, you have up to 5 different access points. In those cases, you have 5 different modems. And if you unify those, you reduce the overall footprint from a technology perspective, and you also put the focus on those extended features rather than just the hardware side of it.
Go ahead. Please go on.
Thank you. Yes, I think interoperability is a great enabler. It makes it operationally easy to focus on a part of the of your mission or your business model, and leave, in some cases, the touch points to ground station, interoperability, not having to develop the entire chain of providers and equipment that you need to support what you're trying to do. Definitely, I think, eases the execution of, especially, I think, new systems and innovative systems. We are thinking about comms missions, but there are a whole host of other missions that especially focused on LEOs, small LEOs, where if they didn't have to build the entire ground segment and could just use an existing ground segment as a service to, let's say, downlink their antennas, reach those, at KSAT is a great example of that, being able to leverage that to manage and control the contacts, to offload the data, certainly makes it easier and cheaper. So I think from that perspective, it is it's a good thing. Obviously, that means that it lowers the barriers to competition. It increases the ability for collaboration, but in some cases, that is a double-edged sword. That that companies that are trying to compete based on a marginal discriminator then have to dig deeper and further to really add value to their business. So it can, I think, impose challenges on both sides.
I'm going to add to his point, because if you look at what happens with the cell phones, using his example, we used to be the CDMA, TDMA, GSM, etc. That was like it is today, different brand of modems running in this constellation or that constellation. And that differentiators at the beginning were marginal, but then increase over time. And interoperability, it's on the satellites, and based on even what we're doing right now with 3G, PP, and 5G, and NTN, etc. It's bringing us into that path. But we have to keep into account that whichever is running today a constellation using an iDirect modem or decides to use a Gilad modem, we uses a different waveform. Even though they're running on DBBS2X, or they're running either on MXTDMA or something else, it's their unique infrastructure that requires a satellite change in order to allow those terminal change. And launching satellites and running new constellations like a LEO that requires thousands of satellites to be able to operate, it brings that barrier on how quickly can you adapt to this. A panel this morning was making a reference of the next 5 years to integrate 5G within the structure. And in conversations with new constellations that are being built, they're being built already for 5G. But those constellations that they are already in operation, a conversion into a standard, it becomes a more challenge point. Yes, we all want to reduce costs. We all want to have the ability to be agnostic for our terminals to be able to roam across. But not always is that nirvana dream of executable immediately. We all have to work toward that path. And I believe we're in the right path. 5G, NTN, and the standards defined by 3GPP is the steps that will bring us into that golden route that it will take us to any standards in about 5 to 10, maybe 5 to 10 years throughout. That will be in a very open-minded way.
Yeah. So if, from our perspective, as an existing ground station, as a service operator, I will agree with this first gentleman that the flexibility it provides for our end user, our customers, is of great importance. It will enable them to maybe challenge us more, move to other operators more easily, which is good and bad for us, of course, because we can also take back. Mission integration will, of course, be much less worky for us if we can do it the same way with everyone. We will avoid the vendor locking. And this with cooperation with others. I have a very fresh example of that, where we as KSAT needed to have a bigger asset than we really have ourselves. So we partnered with someone which had this antenna. And there was really a lot of work to kind of integrate them into our network. So if this has been more standardized already, this work would have been a lot easier, and we could have done it a lot better job. So yeah, we are really supportive of this work.
So I think I heard a handful of themes from all of you. Certainly cost, driving costs down, driving competition up, and then flexibility of both of, maybe talking to different networks, but also the ability to integrate with other systems more easily. Flipping the script on that, what challenges do you see that may exist that might balance against the value that we all see coming from standards, from open APIs, from better interoperability? I'll give one example. Software-based processing is a growing draw in our industry, kind of throughout. That drives added flexibility, but when you look at, say, a terminal, where there may be competing pressures of driving, smaller size, driving to lower costs to be able to proliferate capability more widely, how do you balance the cost and benefit of standards and interoperability?
Well, I will jump in here, but I think the balance is really important, because when you're thinking about a low-cost terminal capability for communications, you're really going to push that into a silicon as much as possible. That is a cheaper way to... But if you think about the entire use case and all the different missions and capabilities that people want to be able to do, putting it in software is a very opportunistic and also smart way to manage things, because now you can turn your Satcoms, like we're working with some of our partners and extending Satcom beyond communications into other use cases. And we can do that because our entire antenna and terminal is software defined. And so we can change the beamforming, we can change our acquisition and tracking capabilities. And I think that's true for what you're doing on the modem side too. And so there's definitely use cases where that software-defined environment is going to be worth the extra investment on the hardware side. And so there's going to be a trade in the different, whether you're going to really focus on functionality or if you really have a specific purpose-built system.
I can add to that. Yeah, I think when we look at a standard and see its application in real world, I think there are a few things that are really important. The first thing to do is to make sure that the standard itself, we in software we say, modularity is important. I think sort of modularity of standards is important. To say that, don't try to make a standard that is so big that it tries to cover everything, that it becomes complicated and impossible to really follow, in which case it just becomes this mammoth thing that you can't really deal with. Like so having, I think, focus standards, having focus standards that apply to interoperability in a specific area of application, whether it's managing the control plane, whether it's managing communications, whether it's analytics. I think that's important. The other thing that I think is also important is to make sure that the standard leaves room for decision-making for individual projects and missions as needed, and standardizes on the things that are needed. So basically having a standard that doesn't overreach in trying to cover everything, because what happens is that a standard like that becomes very rigid, and in the 3 or 4 or 5 years time that it takes to actually build systems to that standard, the standard is obsolete. So I think there is that balance that needs to be brought in the scope of the standard as well as the applicability of the standard. I think that's really important.
Correct. And open book interfaces is critical for that open standard to work. And one of the key challenges that from before, other companies were always very protective of their IP. This is the way that I operate. This is my secret sauce, etc. It's now defined that if you actually share your ability to communicate control plane, data plane, or even management interfaces to direct point and control systems, it actually enriches your own interfaces by bringing value proposition from partners or co-development environments where you will not be able to do if you have your closed doors. Collaboration it's something that is critical in these eras, and open APIs, it's something that is fundamental among most of the developments we do, because it's the only way to allow scalability. You cannot scale to volume and actually overcome the challenges of cost if you're living in a closed system. And that comes from ages of development of several industries, where now software-defined environment, if you go software-defined modems, software-defined satellites, software-defined antennas these days, you all have to collaborate, speaking the same language. Otherwise, without open APIs, that interoperability or application of the standard become obsolete, as you mentioned, early almost from the get-go. So open environments is not anymore a threat to your IP. It's actually an expansion of your IP.
Yeah. So I will say a few words there about the APIs, open APIs. I fully agree. They must be there when they are needed. That means we can't spend years on creating them. Yeah. We need to move faster. And also important, you need to get acceptance within the industry and make sure they are used across the board. Because if you don't do that, or if you develop too late, people will start creating their own solutions on everything, and then you have it going. So for the balancing of cost, I don't know. So for us as a EU-based mostly provider, we have these unique customers, and we dynamically change between the antennas from support to support, from customer to customers. So we'll need to set up differently for each support. We have done that with the old analog modems as well, FPGA-based modems. A well-known technology, high-performance modems, no doubt about that, long lifetime. But they are expensive for procurement. Yeah, and also for upgrading, it can be challenging for new waveforms and things like that. And you might need several units. So all in all, it's costly. But looking at the digital approach, you should think that there was a lot of money to save in the beginning. But also there you need to have quite capable servers, which also is costly. You have to have high-performing network equipment, also expensive. So when you sum all together and the effort you need to set in initially to get these new ecosystems to work, it's not necessarily so that the dollar per dollar is so much difference that you should think. So when balancing the cost, you need also to consider the flexibility it gives you, and not only count the cost directly. So in the long lifetime, I think that it will have a lower cost to move to this new ecosystem we are building, based on a standard like DIFI and others.
Right. I appreciate that. So I want to talk about kind of different layers of interoperability because it can mean different things to different people. We have a lot of unique perspectives up here, whether we're talking about standards like DIFI or the WAVE consortium, whether we're talking about compatibility layers or flexible ground software that can integrate multiple different ground networks, or even network interoperability akin to cellular roaming. I guess my question is really, what does it mean to your organization? What are the pieces of interoperability that are most important within your portion of the value chain to be successful?
Yeah, I would say that the most important part is the interoperability between the modem and the networks themselves. So waveforms, the IF layer that you mentioned, so DIFI, these things are breaking down the different layers and creating compatibility that allows that interoperability future of how do we go beyond purpose-built networks and purpose-built hardware where we can do more with our terminals than just Satcom communication. We can use it for other things. And so your investment in hardware is maximized. But there's going to be a time in the future where everybody's going to have to make the big leap, both in cost and infrastructure upgrades to make that all happen. And it's worth it. And we're ready there. We're ready to take that leap when that happens in the industry. But at some point, it's got to happen.
So, Piggy, taking that on his statement, one of the critical aspects that I can bring as an analogy, when we were running still on parabolics, before all this new line of flat panels coming for everybody, one terminology was having a system that it will be agnostic to any satellites, being also able to interoperate with every modem available out there. So for us in Intellian, that was something fundamentally from the get-go on a parabolic approach and in the ability to interoperate with every possible outcome. Now, getting into this environment where software-defined modems are more easy to be handled and more available, that is the nature that it brings value to us in order to embrace our customers to run a terminal that is already compatible with the satellites out there. Now also have a sub-layer on the baseband capable to run and overlay themselves across the multiple networks, which currently are not able to work together, but it's a way to bring them together, reducing the cost based on what you were asking earlier, because you don't have to operate now 5, 6, or 10 modems. Now you run a single modem that is software defined, and radios is the next step. Having radios that are software defined is critical, and bringing that to the ground station, it has to have services like yours, where you're serving that new commerce of services. Earth observation is one, because you can work with them to work on the same architectural definition and waveforms and environments that when you're bringing a legacy systems, you have to find a way to adapt yourself, and that's what DIFI and WAVE comes into the play to aggregate them together.
Yeah, I will be try to be clear on your question here. So for us in KSAT, I think maybe the two most important interfaces will be DIFI at the RF side, and the other one, the data plane side on the delivery to the customer, like telemetry, also telecommanding, and the payload data. We feel that there's a gap there because that is not so standardized as you should think. Like for telemetry, telecommanding, you have the SLE interface defined by ESA back in the time, which still is in use and works, but not by the full community. Like the small site community, they don't use that. And it's almost like ESA is the left one. Last one that used this still, and
Space Link extension.
Space Link extension. So there is a variety between our customers how they like to have the data, and that means that it's more complicated to move them from one provider to another. We have to develop based on each customer's requirement. So having this interface lifted up and maybe made this also a standard would be a good thing for us.
Are there any efforts to that effect that you're tracking currently?
No, I don't know. We have our own, and we basically use a lot of the modem vendors' interfaces typically, and that means we have a lot of them.
Yeah.
So having this standardized would be a good thing for us. Those are the two most important, but of course also for the end user and also for us, having a standardized reservation API and maybe an API to exchange ephemeris data, that will also hugely benefit the end user, especially because it will maybe be easier to move around the different providers also. So, yeah, that order I think will be our priority.
Thanks. Yeah, so in terms of interoperability, I see a few different things. For a terminal, say, to be able to interoperate across different systems, you really need analytics compatibility, you need data compatibility, and you need control compatibility. So control compatibility basically means that you should be able to take a terminal that's operating in one system, decommission it out of that system, provision it for another system, and be able to start operating it on that system with compatible parameters, be able to download ephemeris data, to be able to download the parameters, to be able to look at where the satellite is, the frequencies, and all of those things, and be able to get up and running. So, and that's where a lot of times the failing is, and that's where it immediately becomes obvious that this needs to be done. I think in terms of data, there has been a lot more work done to be able to get terminals to interoperate and carry data across things. So I think that's becoming, more and more common. Analytics is a huge other thing. Knowing how a terminal is operating, being able to look at and have visibility over terminals operating across different systems but supporting the same mission, I think is also problematic, so that work needs to be done there. And then on the other side, supporting the actual mission, the physical layer, having terminals that are compatible with multiple missions, multiple bands, terminals like Kymeta working with multi-orbit, software-defined radios that are able to work with multiple bands, multi-band components. I think those are allowing interoperability on the physical layer side. So I think you need all of these things to make a terminal work. Obviously, they all increase cost. They all increase complexity. That needs to be weighed against the benefits for the mission. So a lot of times it's really best to have standards in place that can evolve, and then have terminals that evolve with the needs. So you have Gen 1 that does what it needs to do today to support short-term missions, and then Gen 2 that supports a broader set, and Gen 3 that supports a broader set. I think trying to build something that is going to interoperate long-term across many systems without having an actual use case and a business case for it is oftentimes not a good business proposition. So,
sure. So I want to pick on DIFI a little bit, and I feel comfortable doing that because I think we've all now said good things about it, or we sit on the consortium, but it really helps address interoperability at the data plane. And a couple of you have mentioned the control plane, so I want to pull on that thread a little bit. How important is open APIs on the control plane? I think Blad, maybe you mentioned, people consider that their IP and kind of keep that close to the vest. So I want to kind of pull on that thread and get people's thoughts. From ARKA's perspective, it's very, very important to have totally open, non-proprietary APIs, but I'd like to explore that a little bit.
Yep. So we have currently a deployment that it's ongoing for a LEO constellation where the customer was clear that they wanted it to be able to run any antenna on the same characteristics, doesn't matter the manufacturer. So they ask us to work into define that open API that is going to be driven across the other vendors as well. But the customer had the ability to drive that openness, and we had already defined that for our gateway systems, but we needed it to make it, as I said, widely open. And the interaction with the other manufacturers brought to us that enrichment of the interface enable better interconnectivity with the end customer fulfilling their need. And DIFI is critical for this environment because it allows you to remove the dependency into a single standard that I have to run L-band from this point to this point and bring that networking layer that allows easy transportability and then define already by current networking standards that they've been running for ages. So they're proven, validated, and certified. And that two pieces, when you're able to have open APIs that corresponds to ability to run multiple vendor of antennas over the same control plane, and then you have your ability to carry your traffic without the limitations of the mediums of being an L-band and different frequencies per vendors, and moving it over IP, it enhances dramatically the environment to operate in new constellations and existing ones.
Thank you.
I can say for KSAT, so we created our own open standard in sense of open for our customers. so to do exactly that, and we call it the monitoring API, where we give them access to all of these parameters that you mentioned. And that has been widely appreciated by everyone that uses it, because they give them a very good insight in what's happening during their contacts. They can analyze after. It also helps us improve because we have another way of interacting with them. They know what we know, and we can together with them improve everything. So this is a huge value to our service chain, and I would agree. Having this as an open standard would, of course, make things even easier.
Absolutely.
I just want to pick on that for a second, Tron. Would enabling other ground as a service providers to also provide connectivity to those same customers with that API, is it open to them in that way? Can a customer go and say, AWS or Viasat, I want you to implement this same API?
No, so currently we use it at our own network of antennas, and that's why we built it, because there was a gap there. There was no standard, so we just created it. But clearly there would be a value if this was open for everyone.
Or a standard version.
Or a standard somehow that we could use, or we can contribute making those standards, but that will, of course, give the full community a lot of flexibility.
But, yeah, just to add to that, I think this, what Blad and Tron said, this strategy of, of providing an API based on work that you do, and then essentially dropping it into the open world to say, hey guys, here we have an API, we have a system that works with it. If you guys want to use it, feel free to use it. It's a strategy that I think has a lot of strength to it, because it's something that the software industry has realized, is that when you take a product and you make it into a platform that other people can come and play in and that can collaborate in, the valuation and the scale of that is transformational. It turns a system that is for one mission into a system that's used by people. People come into that, it becomes a community. You have all these players that you didn't ever think would use the system. And I give you an example. NVIDIA, it had this weird, it was a graphics chip. They had this CUDA interface that, people like us who just wanted to play with things started playing with it, and the next thing you know, people figured out how to do massively parallel computing with it, became a whole thing. They made a completely new business out of this thing. So this kind of an approach to developing an API and a standard can really be transformational. You start with something that works, you put it out in the open, let other people use it, and then help it grow, is, I think, a trend. And I think the market has seen that and seen that companies that start with these standards and open them end up getting valuation based on this expected growth of that, not as a system, but as a platform.
Mm-hmm.
I would just add one thing. I see DIFI as having two key benefits. Number one, opening the ecosystem for technologies to add on and be in the path of new functionality. So improving the overall capabilities of that communication link before it gets to a DMOD. That there's a ton of new value that can be added there. So that's kind of the developer ecosystem. And then the other side is we need to break down the stack in order to get fully open standards, and that's 5G, 6G, NTN mapped with that. And this is going to be a really important part, and I think it adds to our what we call our intelligent communication platform, and look forward to that.
Awesome, thank you all. I have one last lightning question, and then I'll open it up to the audience. Mm-hmm. Are there any other consortiums or standards? We've talked a lot about DIFI here today, a little bit about WAVE. Are there any others that us, the audience, should be paying attention to that are going to be the next big thing?
I believe one of the things that we do have to do on software in order to optimize our customers, and it maybe copy it from the infrastructure software like AWS and others, is it containerize our software and try to establish a standard where the containerization of packages that run within the core of our systems allows you to upgrade one module without bringing the system down, which in this world SLAs, whatever time that you have to take down, it's always a challenge. And if you are able to enable a better containerization, and forgive me for my English on this, but it is critical to embrace that confidence from the customer that the software I'm doing or changing allows me to go back and forward if something fell. And that standard, it's already available, and we should embrace it a lot more, especially in the industry. Talking about modems, you want to upgrade the software on the modems, 5 out of 10 times you're holding yourself to praying to make sure it doesn't break. So it's the kind of things that we need to embrace and move forward to it.
Absolutely.
Yeah, I could not agree more. You said it very well.
All right, if there are questions from the audience, please make your way to the microphone. Looks like maybe we have one coming around here. Maybe not. If there are no more, I'll say thank you to the panelists. Thank you to the audience. And have a wonderful rest of your day. Please feel free to come find them after the fact. They'd be glad to talk. I'm happy to chat. And also come visit ARKA at our suite at the top of the elevator.
Thank you very much. Take care, guys. Thank you very much.